Okay, so today in geometry, we are going to start chapter 10, which deals with circles. Today, we're going to talk about parts of a circle. We're going to get a lot of the vocabulary for chapter 10, and then write and graph equations of circles. So let's start out with a circle is the set of all points in a plane that are equidistant from a given point in the plane called the center. A circle with center P is called circle P and can be written. So our notation, we draw a circle, we put a dot in the middle, and then if we're calling it circle P, then we would list the point P. A radius is the segment with one endpoint at the center and the other endpoint on the circle. A chord is a segment that joins 2 points on the circle. Then we have a special chord, which is the diameter. So a diameter is a special chord that goes through the center of the circle. A secant is a line that intersects a circle in exactly 2 points. A tangent is a line in the plane of the circle that intersects the circle in exactly 1 point, and that 1 point is known as the point of tangency. And then I just have provided this picture so that we can see an example of all of these. So this right here, this would be our center. We'll call it C. A chord, again, is any segment that connects 2 points of the circle. So here we have our chord. The radius, the endpoint, one endpoint is on the center, the other endpoint is on the circle. The diameter, the special chord that goes through the center. A secant is always going to cross through your circle because it has to touch in exactly 2 places, so it's going to have to cross through the circle. The tangent line touches in only 1 spot, so it will never go inside the circle. It's always going to be on the outside, and that 1 spot where it touches is known as the point of tangency. So now we're going to practice that using this picture. Determine whether the line, the ray, or the segment is best described as a radius, a chord, a diameter, a secant, or a tangent of circle C. So they give me a segment AC. Right? He told me that this was circle C, so I know this is my center. So segment AC has 1 endpoint on the center and then 1 endpoint on the circle, so that is a radius. The next one, line AB. Line AB goes through my circle and it touches it twice, so that is a secant line, or just secant. Segment FG, FG, 2 endpoints on the circle, so that is a chord. Remember, a chord will always be a segment, not a line. Segment AG, AG, again, this is a chord, but it's the special chord because it runs through the center, so that is the diameter. And then finally, line DE. Line DE only touches my circle 1 time, so that is known as a tangent. It's on the outside of the circle, only touches once. And now we're going to talk about coplanar circles. So 2 circles can intersect in 2 points, 1 point, or in no points. Coplanar circles that intersect in 1 point are called tangent circles. Coplanar circles that have a common center are called concentric circles. Okay, so here's an example of 2 circles with no points of intersection. Okay? So they're one inside of the other. This is an example of 2 circles with 1 point of intersection. They touch each other 1 time right there. So these are tangent circles. This is an example of circles that have 2 points of intersection. This last one looks like a bullseye. Right? So this is where all the circles have the exact same center. So we start small and then we just keep getting larger and larger. These are called concentric circles. So now we're going to talk about what's called common tangents. A line, a ray, or a segment that is tangent to two coplanar circles is called a common tangent. There are two types. You can have a common internal tangent or a common external tangent. So this first picture is an example of a common internal tangent. That's where my tangent goes in between the two circles, touches once and once. Common external, so on the outside of both of the circles. Okay? So if it doesn't go in between the two circles, then it is an external tangent. If it goes in between the two circles, then it's called an internal tangent. So here we have these pictures, and it says tell how many common tangents the circles have, and then draw them. So this first set, I see that my circles touch each other at one point. They have one point of intersection. So these will have 3 common tangents. So the first one right there, the second one on the bottom right there, and then the last one in between them in that one spot. These next, okay, these circles have 1 point of intersection right there, so they will only have 1 common tangent the way that they are drawn, one inside the other, and so that is their 1 common tangent. So now we look at this great big circle and this little circle here. These will have 4 common tangents. I can get 2 common internal and 2 common external, so these will have 4. If I do my external first, there's 1. Go to the bottom. There's 2. That's not a very straight line, but you get the picture. And then we're going to go internal. There's 3. And there's 4. Now we're going to look at these last 2. So these circles overlap. Okay. So they will not have an internal tangent. So these are only going to have 2, my externals. There's 1. And there's our second one. Okay. Now we're going to talk about the equation of a circle. So your standard form of equation with a circle with a center at the origin, so my center would be at 0, 0 here at the origin, is x squared plus y squared equals r squared. The standard form of the equation that does not have a center at the origin is x minus h quantity squared plus y minus k quantity squared equals r squared. The center is h comma k. So whatever these numbers are inside here, those are your center, your x and your y for your center. Notice that they always come out opposite. So this is x minus h, it comes out as a positive h. If this had said x plus h, it would come out as a negative h. And then whatever this is, we take the square root of that to get our radius. We're going to practice that. We're going to identify the center and the radius of the circle. So number 1 says x plus 6 quantity squared plus y squared equals 49. So my center, I have x plus 6. I take the opposite of that. That comes out as negative 6, comma. My y did not have any parentheses, so that's a 0. So my center is at negative 6, 0. My radius is the square root of 49, which is 7. So now we'll come to number 2. X minus 7 quantity squared plus y plus 3 quantity squared equals 13. Our center, so this is x minus 7, so it comes out as a positive 7. This is y plus 3, comes out as negative 3. So my center is at 7, negative 3. My radius, I take the square root of 13. That is not a perfect square, and I cannot do factor tree on it. So my radius is the square root of 13. Number 3, x squared plus y minus 10 quantity squared equals 22. My center, my x did not have any parentheses, so that's a 0. It's y minus 10, so that comes out as positive 10. My radius, I take the square root of 22. That is not a perfect square, and again, I cannot do factor tree on that. So my radius is just the square root of 22. Number 4 says x minus 19 quantity squared plus y minus 127 quantity squared equals 97. So my center, the negative 19 comes out as positive 19. Negative 127 comes out as positive 127. So my center is 19, 127. My radius is the square root of 97. Again, that's not a perfect square, and I cannot do factor tree on that. Two more of those. Number 5, x squared plus y squared equals 81. I don't have any parentheses, so I know my center is at 0, 0. I take the square root of 81, so my radius is 9. Number 6, x squared plus y squared equals 24. Again, my center is at 0, 0. So this time, when I take the square root of 24, I can do the factor tree on that. So I know that that came from 6 and 4. 6 breaks down to 2 and 3. 4 breaks down to 2 and 2. I have a pair of 2's, a 2 and a 3 left behind. So here my radius is 2 square roots of 6. So if you can do the factor tree on it, you do the factor tree. Okay, so now we're going to go the other way. Now they're going to give us the center and the radius, and we want to write the equation of the circle. Again, remember that my center came out opposite. So they tell me that the center was 2, 7. These are both positive numbers, so that means that they were negative inside my parentheses. So I'd have x minus 2 quantity squared plus y minus 7 quantity squared equals, now I have to square my radius, so 6 squared is 36. Don't forget these quantity squareds up here. Without those, you do not have a circle. Okay? Number 2, the center is 74, negative 108. So I have a positive 74, so it would be x minus 74 quantity squared. Plus this was a negative 108, so that's going to be y plus 108 quantity squared. They tell me the radius was 10, so 10 squared is 100. So there's our equation. Number 3, the center is at 0, negative 8. So that means my x did not have any parentheses, so x squared plus negative 8, so that would have been y plus 8 quantity squared. I want to square this to get my r squared, so the radius is the square root of 5. If I square that, the square root of 5 squared is just 5. Number 4, we're going to look at where we have fractions. No problem, same thing. So 1/2, so x minus 1/2 quantity squared plus y minus 3/4 quantity squared equals my radius squared. Again, if I square the square root of 13, I just get 13. Number 5, the center is at 0, 0. The radius is 12. So no parentheses. So I just have x squared plus y squared equals 12 squared, 144. Number 6, again, center is 0, 0. So again, x squared plus y squared. This time 3 squared is 9. Now let's look at this picture. I have circle A, circle B. We're going to write the equation from the picture. So we'll do circle A first. Let's identify what our center is. We see it's at the origin, so that's 0, 0. Our radius, so count how many spaces out. 3. So circle A's equation, x squared plus y squared equals 9. So number 6 up here, that is the picture. Circle A is the picture of number 6. So now let's look at circle B. Again, let's find its center. So we're at 7, 6. So the center is at 7, 6. And then our radius is out about 1.5, it looks like. So 1.5. So this time my equation, x minus 7 quantity squared plus y minus 6 quantity squared equals 1.5 squared is 2.25. Right, our next one. It tells me the point negative 5, 6 lies on a circle whose center is negative 1, 3. Write the standard form of the equation of the circle. I could graph this or do the distance formula because I need to find out how far is it from this point to this point. Okay. Again, if I were to graph it, then I would have to do the Pythagorean theorem. I don't have a graph out here. I'm going to show you the distance formula on this. So remember, the distance formula is the square root of x2, so negative 1 minus x1, negative 5, quantity squared, plus y2, 3, minus y1, 6, quantity squared. Negative 1 minus negative 5 turns to negative 1 plus 5, so that's the square root of 4 squared. 3 minus 6 turns to negative 3 squared. 4 squared is 16. Negative 3 squared is 9. 16 plus 9 is 25. The square root of 25 is 5. So now I know my center and my radius. Remember, this is our radius. So I can write the equation of the circle, x plus 1 quantity squared plus y minus 3 quantity squared equals 25. Because my radius was 5, 5 squared is 25. The last thing we're going to do is graph some circles. In order to graph a circle, you need the center and the radius. So here, number 1, x squared plus y squared, my center is 0, 0. Equals 49, so my radius, square root of 49, is 7. So to graph it, I plot my center, 0, 0. From my center, I go out my radius, 7, in all 4 directions. So this one is really going to kind of be off our graph. And then I connect those. I draw my circle through those. So number 2, here, my center, x plus 1 quantity squared plus y minus 3 quantity squared. So my center is negative 1, 3. My radius, the square root of 4, is 2. So again, I plot my center first. So over negative 1, up 3. There's my center. Now from my center, in all 4 directions, I go out 2. So I would go up 2, left 2, down 2, right 2. Connect those. This next one, number 3, x minus 4 quantity squared plus y minus 6 quantity squared equals 16. My center, actually let me erase that because I think I'm going to need over there when I graph that. So I'll write it down here. My center is 4, 6. My radius, square root of 16, is 4. So over 4, up 6. So again, this one's going to be off of my graph. There's the center. So now I want to go up 4. There. Left 4, which is going to put me here. Down 4. And right 4. Then I would draw a circle through those points. All right, so that does it for day 1 of chapter 10, introducing us to circles. We got a lot of vocabulary in today. We learned how to identify different parts of the circle, how to write equations of a circle, given the center and radius, how to identify the center and radius, and how to graph them. Your homework will be a worksheet covering all of this.